Hello again, we're still playing with switches. This one is about spanning tree protocol. So in our little switch network here, so far what I've done is I've added VLANs and put router on a stick. So that should all be running quite happily now. All our routing's running as well using RIP. So that our network's getting quite interesting. Within this little portion though, we have a thing running called per VLAN spanning tree, PVST. It's actually PVST plus. So for each VLAN that we've created down on these switches, we've got an instance of spanning tree running. And spanning tree has put this port here into blocking mode. So they've negotiated, actually based on their MAC address to start, and we'll show you that, which bridge, and the switch is called a bridge as well, is going to be the root bridge. We need to go in and actually design it ourselves, because we actually want this top one to be the root bridge, and as it turns out it is, because its MAC address is the lowest on this system. But we need to go through and play around with spanning tree and actually change it up for ourselves, just so they know what we can. So spanning tree is blocking this port, because if it weren't blocked and we send a broadcast into this switch network, the broadcast will go forever. There's nothing stopping a frame going across this network forever if we weren't running spanning tree. You'll end up with a broadcast storm and the network will slow down a hell of a lot. In fact, it could fail. So spanning tree comes in and says, look, if you want a redundant link between these two switches, so that if this link fails everything can go this way, we need to run a protocol in there, which is the spanning tree protocol, and it'll determine, based on the configuration, which ports are going to go into blocking mode. Now this is a tiny network, there's only 3 switches in there. You can have a smaller network actually, you can just have 2 switches and actually plug 2 cables in, and spanning tree will actually run across that as well. But you can have quite large networks. There is a limit to spanning tree. If you've got over 7 hops, then the whole system will fail. So this is small. Let's play around, get used to some of the basic stuff, and then work our way in from there. Okay, so let's just show spanning tree for now. So we'll show it on this switch up the top here, switch 1, and we'll show spanning tree. Now we can show it for individual VLANs, and we might do that actually. It's going to be the same for everything, so for VLAN 22 we'll show it there. So there's our command, show spanning tree VLAN 22. Now there's a bunch of little stuff in here that we need to get familiar with. The root ID is actually the root bridge's ID. In our case it's actually the same as our bridge ID, because this bridge is the root, it says it there. We can actually work out a few bits and pieces. So our priority number is that number, and we've got a MAC address there. So how does spanning tree kind of work? Where do these numbers come into it? This bridge ID is actually used. This bridge ID is made up of a priority number plus the VLAN number plus our MAC address. So for each VLAN we're running an instance of spanning tree. So per VLAN spanning tree, PVST. And each time we turn on this switch network, these switches will go and negotiate between themselves which has the lowest bridge ID. Now by default all their priorities will be the same, so 32768. Because we're running per VLAN, each VLAN number is going to be the same, but the only difference is MAC address. So they will negotiate and determine which is going to be the root bridge. So let's have a look at it down on this switch down here, and we'll have a look at its spanning tree information for VLAN. For VLAN 22 as well, same as we looked at before. So now we'll look at it, and our root ID is the same value that we had on this top switch, switch 1, which is the root bridge. And our bridge ID for this switch 2 down here is actually this value. There's our priority number, there's our VLAN number, and this is our MAC address. So this MAC address number here is higher than our bridge ID value, and that's true. So to determine the root bridge, it's actually that value there, the bid number. So remember, the bid number is made up of this priority number, the VLAN number, and the MAC address. Now there's only one value we can actually change in all these. We can't change the MAC address, we can't change the VLAN number, which means we can only change our priority number. So if we were to go in and design a network and change things up, we would change that value there. And that's what we're going to do. We're going to do a little bit later. So at the moment, oops, sorry, let me just show spanning tree, and this will do all our VLANs. So I've just shown that spanning tree. So for VLAN 1, the root bridge is the top one. This is the root for VLAN 1. For VLAN 22, this is also the root bridge for VLAN 22. For VLAN 33, this is the root bridge for VLAN 33. For VLAN 44, this is also the root bridge for VLAN 44. And if we wanted to stay as the root bridge, then that's fine, we can do that. But sometimes, because it's just the MAC address that's determining the root bridge, when you plug in a new switch or do something different, you might find your root bridge ends up being one of these other switches. And then the flow of traffic to get out of your network starts to get a bit weird. It might go up, across, and up, and all the rest. We're going to manipulate that to actually make this the root bridge and work it out from there. Now, within spanning tree, what we want to do is actually block a port. So we want to negotiate and end up with some ports being blocked across our network. In our case in here, if that's the root bridge, which is the first thing that's negotiated, then these two switches go through and negotiate using the shortest path first algorithm, the best path to the root bridge. Now at the moment the cost of each of these links is 19. There's the cost there on our screen. So the cost of this link is 19, that link, and also actually that link up there. These are the three interfaces that we've got running on here. The spanning tree is pretty much running through our trunks. So once the root bridge is determined by the lowest bid number, then the other switches work out the best path. Once they've worked out the best path, they can actually start allocating descriptions or names to these ports. So on our root bridge, the role is designated port. So every port on a root bridge will be designated. That's the name given to it. They'll always be in a forwarding state. There's a few different states in spanning tree, and we'll talk a little bit about that later. If we go to this switch down here and have a look at its port states, enable class, so we show spanning tree. Let's just do it for VLAN 22 there, because it's the same for everything at the moment. So in our case in here, ports 1 and 2 are the actual ones we want to look at the moment. So port 1 or interface FA01, its role is now a root port. It's in the forwarding state. Its cost is still 19. Now a root port says that this switch, its shortest cost to the root bridge is through the root port. So in the negotiation that we've gone through, that Spanning Tree has gone through about bridge IDs and all the rest, it's come up and said, using the shortest path first algorithm, that's the best path up to the root bridge. In our case, it's pretty darn simple here. Therefore, that will become the root bridge. The root port. This other port here, because this switch has lost out on the negotiations, its MAC address is the worst of the lot. We've then created this port. Now it's in blocking mode, which means it will not accept data through that port. It will accept spanning tree negotiations, it will accept CDP, some other stuff, but it's generally blocking most data. Here the role is given as alternate. The other name you can use is non-designated, but it's in blocking mode. Let's have a look at this switch over here and have a look at it. Actually, it's right there already. So port 1 and 2, so port, pretty sure it's port 1 up there. Yep. Port 1, or interface FA01, sorry, is in forwarding, and that's the shortest path to the root bridge. The other two ports there, the other one that we're actually interested in, this one, is a designated port. So the same name given to root bridge ports. So there's a lot of words, wasn't it? Get used to which ports are which, because Cisco exams do go through that. What we're going to do is actually modify our root bridge for a particular VLAN. So in our case we might say, well look, I want this bridge, or the switch 2, to be the root bridge for VLAN 44, just because I want to. In my design, in my head, I want that. At the moment this is actually not too bad. So what we need to do is work out how to change this up a bit. Okay, so we're in switch 2. Let's go in and config stuff. So we're using spanning tree. So type spanning tree straight in there, and oops, keep missing that. What's our options? So we're not going to use port fast just yet. We'll come back to that. That's more of a security thing later on. Mode we'll do in this session. We're just looking at VLANs at the moment. So for VLAN 22 is what I'm going to play with. And jumped a bit ahead there. So spanning tree VLAN 22, we're actually going to change the priority number for this switch for VLAN 22. And there's two ways of doing it. We can set the priority value, so let's go into that. And we can set it in increments of 4096. Now it's a bit weird. The what's the word I'm looking for? The priority values are made up in steps of 4096. Because the bridge priority is a 16-bit number, we actually use the first 4 bits for the priority number. So if you know your binary, you'll know that we can go up in steps of 4096. Every time you add one of those bits, it'll go up in those steps. The other 12 bits are actually used for your VLAN numbers. So we're using, we've seen it already, our bridge ID is made up of our priority number, the first 4 bits of a 16-bit number. The next 12 bits is our VLAN number, so that's VLAN 22, and then we're adding our MAC address at the end of it. So we need to go in increments of 4096. Sometimes you can't remember them, So let's just chuck in 4000 into that, and we'll get up a list of what are the actual allowed values. So what we saw originally was the standard value is 32768. I don't know if you remember that, but that's the default value. So if we want this switch to be the root bridge for VLAN 22, then we need to have a value of priority lower than 32768. A better way of actually saying it is lower than any other switch in our whole spanning tree domain. So we can use 0. It doesn't give you much space to play with. So let's just have a look at that. Let's put in 20,000, so 20, where's it gone, 480. So what we've said there is for spanning tree for VLAN 22, the priority for this bridge is 20480. So let's have a look at what's happened there. So if we show spanning tree for VLAN 22, we're on switch 2. This bridge is now the root bridge. We've changed our roles because all our roles for VLAN 22, all our ports on the root bridge have to be designated. You can see in our switch here through the negotiation we've got no orange lights anymore. There's no ports that are blocking every VLAN. So let's have a look at the switch down here, and we'll show spanning tree for VLAN 22 there. So interface FA01 is now non-designated or alternate and in blocking mode for VLAN 22. So for VLAN 22, that interface there is blocking. This is the root port. There it says. So FA02 is the shortest path to the root bridge for VLAN 22. So yeah, we've modified it around. We can also go back up here and have a look at our bridge ID. Actually no, we won't go there. We'll go back to this one and look at our priority values. So our bridge ID 20502 is a combination of 20480 plus 22. So that's the value we've changed. MAC address is still the same, VLAN number is still the same. We changed that priority there for switch 2. So good. This is now the root bridge for VLAN 22. This one is still the root bridge. This top switch is still the root bridge for VLAN 1, VLAN 33 and VLAN 44. So good. Let's go through and change something a little bit and talk about it. So what I want to do is now, I've made a mistake. I want to make this switch on the left the root bridge for VLAN 22. We're going to do it slightly differently, which is actually the better way I think of actually doing it. So let's go conft and we're going to spanning tree for VLAN 22, and if we put our question mark there, we went this priority way before. We can do that now. We can put a priority value lower than the 20,480 that we put in. Let's go this way. We're going to type in root. Now root has two options, primary and secondary. If I want to make this root primary for VLAN 22, then spanning tree is going to negotiate across this network, look at the priorities or the bridge IDs of the other switches for VLAN 22 and negotiate and come up with its own value. So it's gone through and negotiated. Let's fast forward time a bit there. Let's come back and let's show spanning tree for VLAN 22 again. So let's now have a look what's happened. Our bridge ID has changed the priority because we put in root primary to 16384. It's gone 4,000 and what's the value? 4,096 lower than the next best value across our network. Still uses VLAN 22. Still got the same MAC address, which is the worst on the whole network, but now we are the root bridge for VLAN 22. So we've got a root primary, we've got a root secondary, which is good form to have that, particularly on more complex networks than we have here, and we've got our root bridge up there. We've covered a lot of ground there about spanning tree. By default, when you just turn everything on, spanning tree will kick in and run, and one of these switches will automatically negotiate based on the MAC address that it has and its bridge IDs, and it'll determine a root bridge, and it'll all work quite happily. Might not be the root bridge you want for your network design, but it will work. So you actually don't have to do anything to this whole schema to actually manipulate it and play around with it. But if you do want to improve performance, potentially, and control your network rather than have it control you, then you need to set up different root bridges across your network. So based on your network design, at least this one here, our top switch up there should be the root bridge for everything. We should go in and say that it should be its bid or its bridge ID value should be the best value across this network. And we would put that in as root primary for VLAN 22, VLAN 33 and VLAN 44 at least, because those are the VLANs that we've created in here. And that works quite fine. Okay, so that's per VLAN spanning tree plus. When the system first converges, what we do is we've got a number of different states or modes that the system goes through. We've got states there, so this is in the forwarding state. We've seen before we've got blocking state. But when these switches are actually negotiating, they go through a few states. So PVST plus, the states that it has is when we first, actually let's just go through the states. Actually, we might just have a look at it, so we'll just write our configs onto these switches here. Enable that one, class, and we'll write our configs for these because we have changed them, and that's all good. So let's just power cycle all our devices across the whole system. That's a nice bing. Everything is going to start turning on. So when these switches start turning on, the states that it's actually going to go through, seems to be taking forever. See, it's all orange there. We're going to go into blocking mode first while these switches negotiate who's got the best credentials. So determining the root bridges based on bridge ID. They're shipping out BPDUs, bridge protocol data units, are being shipped around by spanning tree protocol, and we're going through in blocking mode at the moment, so no data is transferring, and we're going through the blocking, then we're listening, we're learning, we're negotiating root bridges for each VLAN per VLAN, and then we'll end up in some state, either forwarding or blocking. We'll determine our root bridge, our root ports, our designated ports, our non-designated or alternate ports, and blocking ports as well. The last option for us under this method, which is PVST plus, is actually disabled, where we can actually disable a port. Now, there's another type of spanning tree, because if you saw this, it actually took a little while to converge. It's about 20 to 30 seconds on a power failure and a change to our system, so it's not super quick, but it's not super slow either. The other option for us is to run a thing called rapid PVST. but we'd have to run it on each of our switches. If we run rapid, we don't go through the blocking, listening, learning, forwarding stages. We actually just have 3 stages. We have discarding, which is kind of blocking, it just blocks all data. Then we're learning, and then we go straight into forwarding. So it's a quicker way of converging. It actually only takes about 2 or 3 seconds to actually converge a switch network with rapid PVST. And we can make our system run rapid. So let's go through and just see how we do that. And we'll enable that. So conf t. So spanning tree mode is what we're actually going to play with. So there's PVST, and we're going to use rapid. So we're going to say switch 3 is going to run rapid PVST, and it's pulled everything down. And we need to run the same for our other switches. Enable that. Conf t, spanning tree mode rapid. Control Z that. We should actually write that change in there, because we will turn off and see the whole system come up again. Enable. And again, spanning tree mode is going to be rapid. And we'll write that one, and we'll write that one as well. Okay, so let's power cycle our devices again. Nice bing. And let's just see if our convergence is a bit quicker in Packet Tracer than what we had before. So the modes again for PVST, ooh, that's a lot quicker, isn't it? Negotiate a lot quicker, at least on our trunks. So rapid does 3 modes as it goes through: discarding, learning, forwarding, and obviously one will be blocking mode as well. PVST goes through potentially 5 different states, but mostly we look at 4. So it goes blocking first, then listening, then learning, then forwarding, and blocking if a port needs to be blocked. So that's it for most of what we're doing with spanning tree. There is another bit I'll put in under a security video, mostly to do with our edge ports down there. So once our switches are configured, we don't want other people plugging in switches down here which have better root IDs, other stuff like that. We just don't want that, so we need to put a bit of edge configuration for security, and to allow our PCs to actually connect a bit quicker as well. But for configuring our spanning tree, that's enough for us. We've changed our root bridges if we want to. We've gone through that through the priority numbers. We've had a look at our bid numbers, changed our root priority to root bridge, root primary, root secondary, sorry, or just change the priority values and know that they go in steps of 4096. We've also changed the mode of spanning tree to rapid, which converges a lot quicker. So that's about it for this one. So thank you for your time listening. Catch you later.